Swayam Prabha, free DTH channel for education.
Good afternoon, everyone. So today we are going to see about the variable separable method again for variables. So in the last class we have seen the variable separable method. So we have solved one or two problems like transport equation. We have did, and then we have did also the heat equation. Also we have solved using the variable separable method. Now we are going to do the same thing for the wave equation and Laplace equation also in this class. So what we considered the last class was we considered this problem ut equal to some c square uxx we consider, and then we consider u of x comma 0 equal to f of x, and u of 0 comma t we consider 0, and u of let's say l comma t equal to 0 we consider, and then we solve this problem. Okay, so this is the one which we did in the last class, and we used the variable separable method to solve the problem. Again, in this class, we are going to do a similar kind of thing, but this time we are not going to use the heat equation, but we are going to solve the wave equation. Okay, so let us see that using the separation of variable how to solve this problem also. So the problem is, I'm just going to consider this problem: utt equal to c square uxx equal to c square uxx. The domain, let's say x belongs to 0 comma n. Okay, x belongs to 0 comma n. And then I have u of x comma 0 equal to I'm going to consider u of x comma 0 equal to f of x. Okay, it's going to be f of x, and u t of x comma 0 equal to g of x, where x belongs to 0 comma l. Okay, x belongs to 0 close to interval 0 comma l, and t is greater than or equal to 0. And I have another condition. Another condition is that I have initial condition. Okay, so u of 0 comma t equal to 0. Okay, and equal to u of l comma t also. Both cases, both are 0. Okay, t is sorry, this is t equal to 0. Okay, this is t equal to 0, and here t is greater than or equal to 0. Okay, so if that is t is greater than or equal to 0, that means nothing is there, because t is not that problem. Because this is the one we need to check. So this problem, let us see how to solve it. Okay, so t is greater than or equal to 0. Let us solve this problem. Once again, what you are going to do is that you are going to do the same kind of thing what we did in the last class. So what you are going to assume is that you are going to assume that u is equal to x of x into t of t. You are going to assume. Okay, x of x into t of t. You are going to assume ut t is going to become like x star x of x into, I'm going to put it like t double dot. Okay, t double dot I can put it, or you can put t double dash. It doesn't matter until you remember what you are integrating or what you are differentiating. Okay, it doesn't matter. So here I'm going to put x double dash of x into t of t. Okay, so you can substitute over there. So once again, what I'm going to do is that if I substitute in this equation, we are going to get x of x into t double dot of t equal to x double dash of x into t of t is going to come. So again, I can divide by x of x by t of t. That's what we are going to do now. Okay, because we are going to get what you are going to get is that this suppose x of x and t of t is equal to 0. You are going to get a trivial solution, which I am not interested. So I'm interested only in the non-trivial solution. So in that case, you can divide that. So comfortably, you can divide, because x of x and t of t is not simultaneously going to 0 all the places. Therefore, you can just divide that. Okay. So what you are going to get is that if you divide that, you are going to get an equation like t double dot of t divided by t of t equal to x. So here I have c square is that, c square is that, c square I have missed here. So I'm going to put the c square over here. Okay, into x double dash of x divided by x of x is going to come. So once again, as we did in the last class, this is a t variable, and this is going to be, this side is completely t, this side is completely x. Therefore, you are going to get a constant u only. Nu is going to be a constant you are going to get. Therefore, I'm going to get two equations. Okay, so equation number 1 is that I'm going to have equation number 1. Equation number 1 is that I have d square x by d x square. Okay, minus nu. So u into x equal to 0 is going to come, and then I am going to have, this is problem number 1, and problem number 2 I have d square t by dt square minus u into t equal to 0 square. So two problems I have. Okay, I have two problems. One is t square x by dx square minus mu x equal to 0. Another is t square t by t square minus c square nu t. Okay, so here t square becomes c square because there is a c square. So minus c square nu t equal to 0 square. Now we need to apply this boundary condition u of 0 comma t and u of l of t. So if I apply that, what I'm going to have, okay, I will just apply and then erase it. So if I apply u of 0 comma t, because I have u equal to x of x and t of t, so u of 0 comma t equal to 0 implies what I'm going to have. I'm going to have x of 0 into t of t equal to 0. Okay, so as we discussed in the last class, same thing. If t is 0, then it's going to become 0 because it's a product solution. Okay, so we are not going to use that. So what you are going to use is that you are going to use t of t not equal to 0, which implies x of 0 equal to 0. Second thing, you have u of l comma t equal to 0. Okay, u of l comma t equal to 0 means again you are going to get x of l into t of t equal to 0. Use the same logic. Okay, you can use the same logic and then you are going to get the same kind of concept you are going to get. Okay, so u of l comma t equal to 0 means x of l into t of t equal to 0. So t of t is not simultaneously 0. Therefore, you are going to get x of l is going to become 0. Okay, so therefore, what you can do is that you can use this one. Okay, so together with this one, I'm going to use this condition. So x of 0 equal to 0 is one condition. X of l equal to 0 is another condition. Now let us solve this problem. Okay, whatever I boxed it, let us solve this problem and then let us find the answer for it. Okay, so let me erase this. We have already found, so we can erase it. So now what I'm going to have, I'm going to use this one. Okay, I'm going to use this problem, case 1. So again, we are going to discuss case 1, case 2, case 3. So case 1, what I'm going to have, I'm going to have d square x by dt square, or I'll write it as x double dash itself. Okay, so let me write it as x double dash minus. I'm going to consider the case nu equal to 0. Okay, so I'm going to consider three cases. One is nu equal to 0, nu greater than 0, nu less than 0. Same way what we did in the last class. Okay, so that's what we are going to consider now. So first you consider nu equal to 0. So in that case, this is going to become like x double dash equal to 0 is going to come. So which implies I'm going to have x equal to, I can have x dash equal to a and x equal to ax plus b is going to come. Okay, I can get that x equal to ax plus b is going to come. Now what I'm going to do, I'm going to substitute this value over here. Okay, so if I substitute x of 0 equal to 0, then what I'm going to have, I'm going to have b equal to 0 is going to come. Because this is 0, so b equal to 0 is going to come. Similarly, x of l equal to 0, if I put, then I'm going to get al plus b is going to come, but b is already 0, therefore this is going to become 0, which implies a is going to be 0 because l is not equal to 0. Now case 2, so let us consider case 2. So case 2 is going to become like nu is greater than 0. Okay, if nu is greater than 0, I can write nu is equal to some nu square, I can write it. Okay, some real number, I can write it. So in that case, what is going to come, I'm going to get a similar kind of thing. Okay, so nu is greater than 0. So in this case, you are going to have x double dash, okay, minus nu square equal to nu square x equal to 0 is going to come, which implies m square minus nu square equal to 0 is going to be the auxiliary equation, which implies m equal to plus or minus nu is going to, okay, m equal to plus or minus nu is going to be the solution for this problem. Therefore, what you are going to get, you are going to get x equal to a e power mu x plus b e power minus nu x is going to be the solution. So now again you use that x of 0 equal to 0. So if you use x of 0 equal to 0, you are going to get a plus b equal to 0, which implies a equal to minus b is going to come. Okay. Now use x of l equal to 0. If you use x of l equal to 0, you are going to get a e power nu l, okay, minus e power minus nu l is going to come, because b e power minus nu l is going to come, but b is nothing but minus a, therefore I can use that. So equal to 0. So now you can see that if nu equal to 0, this is going to be 0 because 1 minus 1 is going to come, but nu equal to 0 means mu is 0. Nu is 0 means already case 1 is discussed. Okay, so therefore nu is not equal to 0. If nu is not equal to 0, therefore this is this is going to be a non-zero quantity. Therefore you are going to get a equal to 0 is going to come. So that means what you got? You got again x equal to x is simultaneously 0, which I am not interested. Here also I am getting x is simultaneously 0, which I am not interested. Okay, so therefore that case we are going to consider case number 3. Okay, let us consider the case number 3. So case 3 is, so this is the only case we are going to get the solution. So again I am going to consider mu is less than 0. So in that case I can write mu is equal to minus mu square, I can write. Okay, if mu is equal to minus mu square, then what I am going to get? I am going to get x double dash plus mu square x equal to 0 is going to come, okay, which implies m square plus auxiliary equation is going to become like m square plus mu square equal to 0 is going to come, okay, which implies m equal to plus or minus mu a is going to come. M equal to plus or minus mu I is going to come. Therefore, I am going to get x is equal to a cos mu x plus b sin mu x is going to come. Now what I am going to do, I am going to use this one. Okay, I am going to use this one. So m is plus or minus mu I. M equal to plus or minus mu I here. Okay. So I am going to use this one. So therefore, I am going to use x of 0 equal to 0 implies I am going to get a cos, okay, mu 0. So mu into 0, so that is going to become like a plus b. This is already 0. Okay, sin 0 is 0. Therefore, you are going to get a equal to 0. Okay. Now x of l equal to 0 means you are going to get, which implies a is already 0. Therefore, you are going to get rid of this one. So you are going to get b sin mu l equal to 0 is coming. Okay. Either b equal to 0. If b is equal to 0, you are going to get x equal to 0 once again, which I am not interested at all. So I am just going to have, in that case, I am going to use this one. So sin mu l equal to 0 means what I am going to get, mu is equal to n pi by n. If I put n pi by n, this is going to become like n l cancel, so n pi is going to come. Therefore, you are going to get mu is equal to n pi by n is going to be giving the solution for this one. So I am going to write where n is any integer you can take it. Okay, I am just going to take a new n. I can take it. So therefore, what I am going to get, I am going to get xn of x equal to, my solution is going to be like xn of x equal to bn into sin n pi by l x is going to be. This is going to be my solution. So if I use this one, you are going to get you are going to solve this problem. Okay, this is nothing but we have already seen the Sturm Liouville problem. So this is solving the Sturm Liouville problem. So again and again we are solving that same problem only. So xn of x is going to become like bn into sin n pi by l into x is going to be, where n belongs to z. So now what you have solved this one, xn of x equal to, so n can be positive or negative or 0. If it is 0, if n is 0, again you are going to get xn of x is going to become 0, which you are not interested. If n is negative, then I am going to get a minus symbol here, because minus n pi is nothing but you are going to get a minus pn is going to come, which is a linear combination of this one x and x only, or linearly dependent only you are going to get. Therefore, I am just going to consider only the positive thing. I am just ignoring the negative thing, because that is also taken care by this number bn is going to come. So therefore, what I am going to do, I am just going to find the I am going to consider this n is n belongs to n, means natural number only I am going to consider. Okay, only those numbers. Now mu n is equal to 0 means, okay, mu is equal to minus mu square. Therefore, this is going to be like minus n square pi square by l square is going to come. So I can use it over here. So now what I am going to do, I am going to consider this problem d square t by or I can write t double dot. Okay, let me write it as t double dot. T double dot or t double dash. Okay, unless until you remember, that is not a problem. Either use double dot or double dash. But remember that this is with respect to, that is with respect to x. Okay, so t double dash minus c square. Okay, and this is minus mu square. Therefore, this is going to become like plus mu c square into mu square is going to come. But mu is nothing but mu n is going to use. For each n, you are going to get a problem for this one. Therefore, I am going to write that as mu n square. Where mu n square is nothing but c n square pi square by l square into t equal to 0. So this I am going to write it as t square t double dot, okay, t double dot plus lambda n square t equal to 0 is going to be written. So lambda n is nothing but c nu, okay, r equal to c into n pi by u. Okay, so c mu n, you can write c mu n. So that is nothing but c into n pi by n is going to come. Now if I calculate the auxiliary equation for this one, this is going to be like m square plus lambda n square equal to 0 is going to come, which implies m equal to plus or minus lambda n I is going to come. Therefore, your solution is again going to become like a cos lambda n t. Okay, remember that here we have put lambda n t. But everything is going to depend on n. Therefore, I am going to give here also bn sin lambda n t. Okay, so remember that I can just put some bn as, but we are going to use abuse of notation in short notice, and then we are going to use the bn only. Okay. So we will abuse the notation bn. We are going to use it because there is some constant only we are going to get. So I am going to use it. So therefore, Tn of t. So this is nothing but Tn of t. Tn of t is this one. Therefore, what I can say is that un of x comma t is going to be Tn of t into xn of x, or xn of x into Tn of t is going to be the solution. Therefore, this is going to become like an cos lambda n t plus bn sin lambda n t into sine nu nx, or I can write it as n pi by lx. Okay. So this is going to be my solution. For each n, I will get a solution. Therefore, what I can put is that I can write linear combination is also going to be a solution. Therefore, u of x comma t I am going to define this way. Okay, u of x comma t, u of x comma t is going to be like this. It is going to be summation. I'm going to write like linear combination, but I'm going to take one as a combination. Even if it is Cn also, if you put that, I'm going to push it inside this an and bn. Therefore, that is going to come. Okay, so Cn a of x comma t is going to be the solution. So that I can write it as summation. Okay, an n equal to 1 to infinity. Okay, an cos lambda n t plus bn sin lambda n t into sin n pi by L x is going to come. Okay. So this is going to be where you see this one. This is almost like you got a Fourier series thing. Okay, so this is almost similar to what we got in the Fourier series also. That's what I'm going to use it here. Now what I'm going to do, I'm going to use this. So this is u of x comma t is going to come. Now we have two more conditions unused. If u of x comma 0 equal to 0, dt of x comma 0 equal to g of x is there. That we are going to use it, and then we are going to get the answer from it. Okay. Now here this lambda n's, so this function, this un of x comma t is equal to tn of xn comma tn of t into xn of x, or this an cos lambda n t plus etc. So this is called the eigen functions corresponding to this wave equation. Okay, corresponding to the eigen value lambda n. Well, lambda n is nothing but c n pi by n. Okay, so this is the eigen value, and this collection of all these eigen values are called spectrum. Okay, which is called the spectrum of the problem. Now we are going to so e of x comma t we have time. Okay, now we are going to use the initial condition. These two initial conditions I'm going to use, and then going to get the answer for this one. So e of x comma 0, which is going to become like, if I substitute it over here, this is going to become like an cos n lambda t plus bn bn will cancel. Okay, an is going to, only an is going to be there. Okay, an into, you are going to get u of x comma 0 equal to f of x equal to, you are going to get a summation n equal to 1 to infinity an sin n pi by Lx is there. Okay, this is going to be your u of x comma 0. So this one, since f of x equal to summation n equal to 1 to infinity an sin n pi by Lx, this is nothing but a Fourier sine series is there. So I can just get the answer for this one. Okay, you can just use the Fourier sine series expansion to get the answer for this one, and then you can get the exact values of this ans can be determined from that. Similarly, if I calculate ut of x comma 0, ut of x comma 0 is going to become like, this is going to be sin lambda n into sin lambda n t is going to come. This is going to become like bn lambda n bn cos lambda n t is going to come. Now ut of x comma 0 is g of x. Therefore, this is going to become a g of x equal to summation n equal to 1 to infinity. You are going to get lambda n into bn into sin n pi by Lx is going to come. Okay. So therefore, what you can do, you can use this condition to calculate again bn also. So bn is going to be in terms of lambda n and Fourier series expansion is going to come. So this is going to be the general solution. The ans and bns are determined from this one. So an is nothing but, you can calculate this one using the Fourier sine series. So that is going to become like 1 by 2 by L 0 to L f of x into sin n by x by L. So again, you are using the properties of the trigonometrical system, which is going to, we are exploiting that, and then we are going to get that answer for that. So that is going to give you the answer for your wave equation. So in general, this is the equation, and you can get what is your an is going to become like 1 by 2 by n. Okay, 2 by n integral 0 to L f of x into sin n pi by Lx is going to be there. Similarly, bn is going to become like 1 by lambda n is going to be there. Okay, lambda n will be there, and then 2 by L will be there. So lambda n is nothing but c n pi by L. So L get cancelled. So you are going to get 2 pi c n pi is going to come. Okay, integral 0 to L g of x into, okay, you are going to get sin n pi by L x dx is going to come. So this is going to be your final solution is going to come. Okay. So actually we can write this one. So here you are going to get sin cos lambda n t and sin lambda n t is there. So if you combine this one, you are going to get cos lambda and sin n pi is there, sin and lambda and sin n pi is there. So I can use cos a plus b, cos a minus b formula, and sin a plus b, sin a minus b formula, and then we can get this equation in this format. Okay, we are going to get that in the next few minutes once you are using the problem in D-Albert's method, which we are going to explain. So in that case, you are going to get this one. So f of x plus ct plus g of x minus ct is going to come. So a similar kind of thing is going to come from here also. If you use the sin a plus b and sin a minus b, cos a plus b, cos a minus b formula, which we will see it in a few minutes. Okay, let's see that. Okay, now next one what I'm going to do is that a similar kind of problem, but I'm going to solve the Laplace equation. Okay, so we have solved the parabolic PDE, which is nothing but the heat equation which we solved, and then now we are solving this hyperbolic PDE, which is nothing but this wave equation. Now next we are going to solve the Laplace equation. Laplace equation is the elliptic PDE which we are going to solve. So for the elliptic PDE, what I'm going to do is that a similar kind of problem I'm going to propose. Okay, so here what I had is for this problem the physical interpretation, you know that this is going to be a rod of length 0, L for this wave equation, and let's say this is a string, and this string I'm just disturbing in the upward axis. Okay, this is going to be bidirectional. Okay, just disturb. Therefore, it is going to be disturbed, and then you are going to observe how the behavior is going to be there. Now, in this problem, you can see that physical interpretation also you can see that. So I'm just saying like u of x comma 0 equal to f of x and ut of x comma 0 equal to g of x means initially the displacement I'm just going to say like f of x I'm just displacing, which everywhere I'm displacing, and then velocity also I'm giving ut of x comma 0 also I'm giving like g of x I'm giving. However, these two endpoints are fixed. Okay, you are kept it in a string, violin string, let's say. So these two pretties are fixed, means this is not going to move. Okay, it is going to be fixed. So that's what the second condition is implying. U of 0 comma t equal to 0, U of L comma t equal to 0 is I'm just keeping it in a fixed position that is not moving at all. Okay, so that's the thing we have. Now if we go for the Laplace equation, in Laplace equation, what I'm going to do is that I'm going to do and let me explain like what we are going to do. So in this case, I'm going to take a square domain. Let's take 0 comma a, okay, and then I have 0 comma b is there. Okay, this is the rectangle I'm having. So in this rectangle, I'm going to describe the condition here. So let us write that equation and then I will explain. So I'm going to consider the Laplace equation now. So for Laplace equation, what I'm going to consider is that I'm going to consider this problem uxx plus uyy equal to 0 is there. So that's the problem I'm going to consider in the interval x belongs to 0 comma a and y belongs to 0 comma b is there. Okay, this is the interval I'm going to consider. And I'm going to impose some conditions. So u of x comma 0 equal to 0. Okay, and then u of x comma b equal to u of x comma b equal to f of x I'm going to consider. Okay, where x belongs to 0 comma a. Okay, and then I'm going to consider u of 0 comma y equal to 0, u of y comma 0 comma a comma y equal to 0. Okay, where y belongs to 0 comma b. Okay, so this is the problem I'm going to consider. So for this problem, again we are going to do the same thing. So let me explain what this problem is. So suppose you have a domain, okay, rectangle is there, so 0 comma a cross 0 comma b is there. So in this case, I have the condition only I'm going to explain. So here what I have is you have three different types of problems are there. One you can put it like u equal to f1 here, u equal to g1 here, okay, u equal to f2 here, okay, and u equal to g2 I'm going to write. So top boundary, bottom boundary, top boundary, left boundary, right boundaries are there. Okay, if all the boundaries are prescribing exactly the values at u equal to if prescribing, that means it is called Dirichlet boundary condition, and this problem is also called as Dirichlet boundary value problem. Okay, so instead of that, suppose I calculate the normal derivative. Normal derivative means what I'm going to calculate is that I'm taking the derivative in this direction with respect to the normal vector. I'm taking dot product. So this is outward normal, this is outward normal, this is outward normal, and this is outward normal. So I'm going to take the dot product with that the derivative dot product with the normal vector. So in that case, I can prescribe dou e by dou n equal to f1 here, similarly dou e by dou n equal to g1 here, similarly dou e by dou n equal to f2, dou e by dou n equal to g2. So I prescribe this one. So in all the cases, I have a normal derivative. So this is called Neumann boundary condition. So in this case, this problem is called as Neumann boundary value problem. So instead of that, suppose I give something like here, let's say like u is there. Okay, here I prescribe u, and here I prescribe u equal to f2. Whereas in the other two places I am prescribing Neumann boundary condition, then that is called mixed boundary value problem. Okay. On the other hand, you can put alpha u1 plus beta u2 also. Alpha you can write this way everywhere. Okay, alpha 1 u1 plus alpha 1 u plus beta 1 dou u by dou n, okay, equal to f1. Similarly, you can write everywhere. Then that problem is called rapid boundary. Okay, let's forget about that. These are all the things which we need to know, like what is the fixed boundary value problem, what is the normal boundary value problem, what is the mixed boundary value problem. So that's the one which we have. Okay, and also in general, one more thing. So you can write this problem like whatever you have. So you can write uxx plus uyy. This uxx plus uyy can be written as del u. Okay, del u means del is nothing but, I'm going to denote del is nothing but delta u. Uxx plus uyy equal to delta u. So del means what you are going to have is that delta is going to be delta term. The del is an operator, the gradient operator. The gradient operator is defined this way: dou by dou x, dou by dou y. Okay, so in this case you can say like this is the gradient operator, and taking the dot product with its help is called the delta operator or Laplacian operator. So that is going to be the problem over here. So this can be generalized for the higher dimension also. What you can write is that you can write del equal to 0. That means it is a Laplace equation in the n dimensional variable also. Okay, you can write in the n dimensional variable also. This is going to be the Laplace equation. Okay. So if you want to prescribe the heat equation in the 3-dimensional or higher dimension, similarly you can write that ut is equal to del u. You can write it. Same for the wave equation also. You can write ut equal to del u. Okay, this is the wave equation and heat equation in the other topics also. Okay. Now what we are going to see, our interest is to solve this problem using the variable separable method. Okay, so let us solve this problem using variable separable method. So once again we are going to use the same kind of logic here. Okay, what we are going to assume, we are going to assume instead of uxx plus u equal to xxx, I am going to rewrite this problem. Okay, I will erase the rest of the things. So I will write this equation once again. So what you are going to get is that, let me erase this one also. So what you are going to get is that you are going to get a similar kind of thing. So you are using u of x comma y. Okay, so here you are going to get u of x comma y. I am going to write as x of x into y of y. Okay, so therefore if you substitute over here, you are going to get x double dash of x into y of y, same logic. Okay, plus y double dash of y into x of x is going to come. Okay, equal to 0. So therefore this one again you take x of x by x divide by x of x into y of y by assuming is that it is not simultaneously 0. If it is simultaneously 0, if one of them is simultaneously 0, then u is going to become 0, which I am not interested in. So therefore it is not going to be 0. So therefore I can divide that. So in this case I am going to get x double dash by x equal to minus y double dash by y is going to come equal to constant, again same thing. So this is x function of x, this is function of y, and both are so this is function of x and this is function of y. Therefore that is going to be constant only. That is only constant is the only possible thing. So otherwise it is not possible. So in that case what you are going to get, again you are going to get two problems. One is d square x by tx square minus nu x equal to 0. Okay, this is problem number 1. And problem number 2, I have d square y by dy square minus actually plus, okay, mu y equal to 0 square. Okay, so this is the one which you are going to get it in this case. Okay, now let us solve this problem once again. So we are going to consider again the boundary value. So u of 0 comma y and u of a comma y I am going to consider. So if I consider u of 0 comma y equal to 0, okay, u of 0 comma y equal to 0, which implies that I am going to get I'm going to get the Sturm-Liouville problem once again. Okay, so x of 0 into y of y is going to come. X of 0 into y of y equal to 0 means what I am going to get, y is nothing but if y is simultaneous 0, you are going to get u is going to become 0. Therefore I am not interested in that. So we are going to get in this case y of y is not equal to 0, it means x of 0 equal to 0 is going to come. Okay, so therefore first I am going to have one condition x of 0 equal to 0. Okay, second one again u of a comma y equal to 0. So therefore you are going to get x of a into y of y equal to 0 is going to come. So therefore you are going to get x of a equal to 0 is going to come. Again the same logic. So therefore you are going to get x of a equal to 0 is going to come. Okay. So these are the two. So I'm going to solve this problem. Okay, this is a Sturm-Liouville problem. Again you can use the same logic here. Okay. So if I use u equal to 0, then x double dash equal to 0, x equal to ax is going to come. Okay, x equal to ax plus b is going to come. X of 0 equal to 0 means you can say that b equal to 0. Okay, Now L is there. So in the place of L, I have A here. Therefore, this is going to become like I can say like this is instead of A, I'm going to get A1 that case. Okay. So therefore, A1 into A equal to 0 means you are going to get A1 equal to 0. If A1 equal to 0, you are going to get this is completely 0. X equal to 0 is going to come. But I am not interested in this one. Okay, I am not interested in this one. So let us remove that. Now case 2, you can take mu greater than 0, which implies mu equal to mu square is there. So in this case, once again, you are going to get x double dash minus mu square x equal to come, and m square equal to m square minus mu square equal to 0 is going to come, and m equal to plus or minus mu square to come. Therefore, your x is going to become like a e power mu x plus b e power minus mu x is going to come. So once again, use this boundary condition. So x of 0 equal to 0 means a plus b equal to 0, which implies a equal to minus b. Now x of a equal to 0 means what you are going to get is that you are going to get a e power mu a minus a e power minus mu a is going to come, because this minus is coming because of b equal to minus c. So which implies once again what you are going to get either mu equal to 0 or you are going to get a equal to 0. So mu equal to 0 means already the case is there. Okay, otherwise this is non-zero number. Therefore this is going to be not equal to 0. Therefore only a is going to be 0. Therefore x is equal to 0. I am not interested in this case also. So that case once again we are considering. So case 3 is mu less than 0. So mu equal to minus mu square. So x double dash plus mu square x equal to 0 is going to come. Therefore your auxiliary case is going to be the roots of m equal to plus or minus pi, and x is going to become like a cos x plus b sin x is going to come. Okay, so that's what we have here. Okay, that's what we have here in the slides also. Okay, mu equal to 0 we have considered, and mu equal to mu square also we consider, and mu equal to minus mu square we are discussing. Okay, so in this case once again I'm going to have, I got to use this one. X of 0 equal to 0 means it is going to become like a cos 0 equal to 0 is going to come. So a is going to become 0. Okay, a cos u 0 is nothing but a. So a equal to 0 is going to come. Now x of a equal to 0. Okay, if x of a equal to 0, therefore you are going to get b sin u a equal to 0 is going to come. Therefore nu n is going to become like n pi by a is going to come. Okay, because once again the same logic, p equal to 0 means completely 0 is going to come. So only sin nu a I am going to take it as 0. Therefore we are going to get x1 of x equal to bn into sin n pi by a into x is going to come. Use the same logic whatever you did that to come to the conclusion that n is only the positive integer is going to come. Okay, we are going to get the only positive integer is going to come. Remaining things I just ignore. Now we are going for the next one. Okay, so here I will erase that because this is not going to be the same thing. So I will erase and we will compute this one. So I'm going to erase this one also. Okay. So in this case, we solved one problem. Problem number 1 is solved. Now problem number 2 we have solved. So for problem number 2, what I have, d square y by dt y square is there. Okay. So in that case, I got to consider y double dash plus nu. So nu is nothing but n pi by a. So therefore this is going to be like n pi by a. N pi by a, and minus mu I got to put. Okay, mu equal to minus mu square is there. Therefore this is going to become like minus n pi by a whole square into y is going to come equal to 0 is going to come. Therefore auxiliary equation is going to become like m equal to plus or minus n pi by a is going to come. Okay, m equal to plus or minus n pi by a is going to come. So I'm going to write, therefore this I can write as y equal to a e power. Okay, so here a n is there. Therefore I'm going to get a n e power n pi by a plus bn e power n pi by a. I'm going to write it. Okay, this is going to be my minus n by b. This is going to be my solution for this problem, y double dash minus n pi by a whole square. So I'm going to denote this n pi by a, lambda n. I'm going to denote lambda n is nothing but n pi by a. I'm going to denote. So in that case, this is going to become like okay. In this case, I'm going to get so here no cn is going to come. So nu n is nothing but your or I can just keep it nu n itself as there is no lambda n is required here. So lambda and nu n is going to be same here. Okay. So therefore this I can write as this is going to become like I can write this as a n e power nu n y plus b n e power minus nu n y. Where nu n is nothing but n pi by a, that is going to be your eigen values. Okay, these are the eigen values, and again I can write u of x comma y or u n of x comma y corresponding to the eigen value. I can write as x n of x into y of y. Okay, x n of x into y n of y. Okay, so in this case this is going to become like you are going to get a n e power nu n y plus b n e power minus nu n y into sine. I'm just again abusing notation. Suppose it should be bn and then it can be cropped in that. Okay, you can just you can just observe it inside that. So therefore, you are going to get sin n pi by a into x squared. Or I can write it as this n pi by ax also. I can write it as nu n because we don't have two different notations now. So nu n x also I can write. So once again, same logic. What you can do is that this is going to be the eigenvalues. This is going to be your eigen functions, and your eigen spectrums are going to be n pi by a is going to be okay. Set of all n pi by a, where n belongs to n is going to be the eigen spectrum is going to be. Okay. So again, now the linear combination of this again going to be the solution. So therefore, I can write u of x comma y same way. I can write u1 of x comma y. I can write it. Or even if you put some constant also, it's not going to be a problem. So that cn is going to be absorbed inside the an substitution. Again, as absorb notation. So therefore, you are going to get summation n equal to 1 to infinity an into e power nu n y plus bn into e power minus nu n y into sin nu n x squared. Okay, so this is going to be my u of x comma y squared. So I have used these two conditions. Now remaining two conditions, these two are not used. So that I'm going to use those conditions. Now u of x comma 0 is going to become like u of x comma 0. That is going to become like, if I substitute it over here, this is going to become like summation n equal to 1 to infinity an plus bn into sin nu n x is going to come equal to 0. So here each term is going to be 0. Okay, each term I can equate to 0. Therefore, sin nu n x term if I equate, then what you are going to get is that you are going to get this one as an plus bn equal to 0 is going to come, which implies an equal to minus b. Okay, therefore what you are going to get, your u of x comma y is going to become like this. U of x comma y is going to be summation n equal to 1 to infinity an into e power nu n y minus e power minus nu n y into sin nu n x is going to come. Okay, but we know that sin h is nothing but sin hx is nothing but e power x minus e power minus x by 2 is going to come. Okay, so I'm just absorbing that 2 also inside that an. So therefore what you are going to do is that this one in general you can write it as u of x comma y equal to summation n equal to 1 to infinity an sin h nu n x nu n y into sin nu n x. I'm going to do. Note that I am abusing the notations of ans and bns again and again. This is supposed to be an by 2 should become from here, but I am abusing the notation and I am going to write that down. Okay, so keep remembering that. So therefore, what I am going to get, I'm going to get this one. Now I need to calculate only an. So how do we calculate the an? We have left with only one more condition, which is u of x comma b. So if I substitute u of x comma b, then we are going to get it like summation n equal to 1 to infinity an into sin h nu n b into sin nu n x is going to come. Okay, so you can use this. So this is equal to f of x is there. Okay, again you use the Fourier sine series expansion. Okay, using that you can calculate the values of the ans. Okay, the an sin h nu n b you can calculate. So that is going to give you an is going to become like, so if you substitute that, we are going to get your an is going to become like 2 by a into, so sin h is going to be there. Okay, this is going to be remaining. So sin h nu n b, okay, integral 0 to a, okay, f of x into sin nu n x is going to be remaining. All terms are going to become 0 because of the orthogonality properties of the sin nu n x. Okay, so therefore this is going to be where an is going to be obtained. So this is going to be, in general, you are going to get the answer. So u of x comma y is going to be, for this problem, you are going to get u of x comma y equal to summation n equal to 1 to infinity an sin h nu n y sin nu n x is going to come, where an can be estimated using this formula. Okay, so this is called your Laplace equation solution. So in general, if you are having, if you are changing that instead of this one, if you are changing, instead of putting fx over here, if I put fx over here, then accordingly you can change the computations over here. Okay, so in that case, your bn will be here. You will get again you are going to get 0 only. So again you can just prove that that is going to become like sin hn is going to come. Okay, so if you are just shifting it over here. Similarly, if I shift it over here also, you will get a similar kind of thing. So the relations will change over there. So instead of putting 0 here, if I put 0 over here, I can change my problem from here to there, and then I can solve this problem for y dash of y by y of y first, and then I can solve for x dash of x by x. And then you are going to get a similar kind of that, but small changes will be there in your problem. Okay. So the small minor changes will be there that you can observe as an exercise you can use. So I'll give two exercise problem now. So what I'm going to have, I have as I have mentioned here, okay, I have a rectangle 0, a, 0, b. So I have top, bottom boundary, top boundary, left boundary, and right boundary. So I can take the top boundary of this problem as f of x equal to 110 and a equal to 20 and b equal to 40 you can take, and then you can solve this Laplace equation. Similarly, second problem you can take the Laplace equation with f of x equal to 100 sin pi x by 2, a equal to p by 2. So in this case, once again you are going to get here you can see that un is nothing but n pi by 2. So you are going to get f of x is going to become like sin 100 sin pi x by 2 is there. That means you are going to compute only for the first term only you are going to evaluate. Okay, n equal to 1 term only you are going to evaluate, and then you are going to get the answer for this a. Okay, that's going to come for the answer. Now next one, this is for the wave equation. So for wave equation, once again you can take fx equal to 0, you can take it, okay, and then g of x equal to sin 3 pi x and g of x equal to x square 1 minus x, you can take it, and then you can solve the problem. You can find what is your solution, what is your ans and bns is there available in that, okay, and then you can calculate it. Okay. An is going to become 0 because f of x is 0, therefore you are going to get your ans as 0. Only bn will be there, so bn you can estimate using this Fourier series expansion, and then you will get the answer. Now next one, so the last one for today. So what we are going to discuss is, we are going to discuss the wave equation again, but in a different perspective. So this perspective is coming in terms of the transport equation. So we are going to use the transport equation and exploit that solution. Okay, whatever we applied from that we are going to use it for the finding the solution of the Laplace wave equation. How are we going to obtain that? Let us see. Okay, if we can find the answer for that, then we can solve that problem. So let us solve that problem now. So what is my problem? My problem is same thing. UTP equal to c square ux is there, and then I have u of x comma 0 equal to f of x, and ut of x comma 0 equal to g of x is there. So these two are given. Okay. So for this problem, how do we find the answer for them? Okay, so that's what we are going to do now. Where x belongs to 0, l and t is greater than 0, you can take. Okay, so you can take even for the general setup also, you can take it, not a problem. Even minus is okay. Now what we are going to do? We are going to solve this problem using the properties of the transport equation. So we know from the transport equation, suppose this is my problem, ut plus cux equal to 0. Okay. So in this case, what you are going to do? You are going to use, you are going to get your, and it is given that u equal to g, okay, or u of x comma 0 equal to g is given, okay, or I can like u of x comma 0 equal to g, g of x is given. So in this case, you can see that u of x comma t is going to be the solution, like g of x minus c is going to be, okay. So here also I am using g, therefore I am just replacing this with h, so therefore you will not get confused over once you have that. So u of x comma t is equal to h of x minus ct is going to come. Okay. Now what we are going to do? Suppose ut plus cx equal to some ut plus cux equal to some a of x is there. Okay, some a of x is going to be there. Means non-homogeneous is there. Then you are going to get u of x comma t equal to h of x minus ct. Okay, plus integral, you will get some a of y is going to come. A of y dy x minus ct to x plus ct is going to come. So that we are going to get it in terms of a of y to dy. Okay. If you are solving the non-homogeneous part. So this is not in your syllabus. I'm just giving the idea. This is the one which you are going to use it. So you can just refer it. How do you solve this non-homogeneous part also? So here it is going to become like x minus ct to x plus ct will come. Okay, so that is going to be your solution is going to come in the case of non-homogeneous part. Now what I am going to do, I am going to use this property and to solve this problem. Okay, so what I am going to do, I am going to use this property to solve. Let us see how to solve. So I can write this problem. So this problem is nothing but I have dou square u by dou t square minus c square, dou square u by dou x square is there. So this one I can write it as dou by dou t square. Okay, dou square by dou t square minus c square dou square by dou x square of u. I can write it. So this one I can split it this way: dou by dou t minus dou by plus I am going to write first. Okay, c into dou by dou x into dou by dou t minus c into dou by dou x I am going to write of u. Means I am applying first on this one and then I am going to apply this one. So that is same as this one you are going to get. So now what I am going to do, I am going to call this one as B. Okay, I am going to call this one as B. So what is my B? B is nothing but dou u by dou t minus C into dou u by dou x is going to be. This is my first problem. Okay. So next one I am going to have. So if I apply this one, then I am going to get 0 equal to dou v by dou t plus C into dou v by dou x is going to be. This is my second problem. Okay, I can split it into two things. Okay, so I have utt minus c square exs. So c is missing there. C square is missing there. Keep remembering that. Okay, c square is missing there. So that is the one which I have. So dou by dou t plus c into dou by dou x. Dou by dou t minus c into dou by dou x is going to be equal to 0. So now what I am going to do, I am going to use this as I mentioned, d equal to dou by dou t minus c into dou by dou x. I am going to take it. So therefore, this is going to be like I have this problem is nothing but dt plus c into vx is going to be there equal to 0. So I can see that vt plus c dx, wherever u is there, I have v, vt plus cx equal to 0, and u of x comma 0 equal to h of x is there. I don't know what is my h of x, so I'm going to get some boundary condition I'm going to use it. Okay, some initial condition I'm going to use it. So some initial condition like a of x comma 0 is going to. Okay, suppose a of x comma 0 is given, d equal to a of x comma 0 is there. Suppose it is given that b of x comma 0 equal to a of x is given. Okay, we are going to find this from this one later. We'll see that what is the a of x is going to come. Suppose it is given b of x comma 0 equal to a of x, then what you can solve is that you can use that property and then you can use the transport equation, then you can solve that. Therefore, this is going to become like b of x comma ct is going to become like a of x minus ct is going to become. Okay, b of x comma t is equal to a of x minus ct is going to become. Okay, now we are going to get, so we are going to exploit this and then again solve this one. So now second problem. So this problem is going to become like, so this problem I am going to consider this as ut minus c ux equal to v, but v of x comma t is nothing but a of x minus ct. Therefore, this is going to become like a of x minus ct is going to come. Okay. So again, we can consider this problem to solve as I mentioned over there. So this one. So in this case, what you are going to get? You are going to get u is equal to we are having u is equal to h of x is there. So in this case, I have u of x comma 0 equal to f of x is there. Therefore, I am going to get f of x plus ct is going to come. Here minus is there. Therefore, it is going to be plus ct. Okay, if it is plus, you are going to get minus. If it is minus, you are going to get plus. Plus, I have this non-homogeneous term. So that is going to become like I am going to use that x minus ct to x plus ct. Okay, x minus ct to x plus ct. Or I can write 0 to t. Okay, I am going to write this 0 to t. This is what we are going to get. So 0 to t. Okay. A of x minus, okay, cs, I'm going to denote another one, minus c of x minus t is going to. Okay, this is going to be my, this is going to apply from here. Okay, a of x minus ct is there, therefore I'm going to put css, and then I'm going to use that ct is going to come here, x minus ct is going to come, so I'm just going step by step. So here I will put x minus ct to x plus ct, and I'm going to use it. So instead of that, I'm going to put it over here. Okay, ds is going to come. So this is nothing but I can just simplify this. This is going to become like minus 2cs, okay, minus 2cs plus ct is going to come into ds is going to come. Okay, so I can use this one to solve the problem. So therefore, that is going to become like f of x plus ct is going to come. Now I can use this one ut. I am going to use it. Okay, so that I am going to use it. So this one I am going to simplify a little bit further. X plus ct I am going to use it, and then plus 0 to t. Okay. I'm going to put a substitution. So let us take y equal to x minus 2cs plus ct. Then dy with respect to ds we are differentiating. Therefore, we are going to get minus 2c. Therefore, into ds. So, so this is going to become like a of y into minus 2c is going to come. Okay, into ds is going to come. Okay, so sorry, ds by minus 2c is going to come. Okay. And then we are going to use this y equal to, if I put y equal to 0, this is going to become like x plus ct. Okay, y equal to 0 means s equal to 0 means y equal to x plus ct. S equal to t means it is going to become like 2cs 2ct minus plus ct is going to come. Therefore, this is going to become like y equal to x minus ct is going to come. Therefore, this is going to become like x minus this is going to become dy by 2c. So x minus ct to x plus ct is going to come. Okay. And then I can sorry. So this is going to become like I can write this as integral x plus ct to x minus ct. Okay, and then I have a of y into dy divided by minus 2c is going to come. I'm going to take this minus 2c out. Therefore, this is going to become like 1 by 2c. Minus is that. Therefore, I can interchange this integral x minus ct to x plus ct. A of y dy is going to come. So this is going to be my problem is going to come. Okay, this is going to be my u of x comma c, x comma t. Now ut of x comma t I can find it. Okay, ut of x comma 0 I have. So ut of x comma t first I got to find. So ut of x comma t is going to become like f dash of x plus ct. Okay, f dash of x plus ct into c is going to come. Okay, into c is going to come. F dash of x plus ct is going to become like c into, okay, that I don't require now. Okay, now this is that. Now what we remain is that we need to calculate what is our a of x. So this is that we are going to estimate this one. So what is our a of x that we need to calculate? Okay, that is one thing which is remaining. Let us calculate that. So what is a of x? A of x is given as b of x comma 0. A of x is nothing but b of x comma 0. But what is b of x comma 0? B of x is nothing but ut minus cux. So therefore I can put t equal to 0 here. Therefore this is going to become like ut of x comma 0 minus c into u of ux of x comma 0 is going to come. Okay. But what is ut of x comma 0? That is nothing but gx. Okay, that is nothing but gs minus c into ux we got to find. So from here I can calculate my ux. Okay, from here. So this implies ux is going to become like f dash of x minus x plus ct. Okay, into 1 is going to come. So that I'm not going to keep it. And then I got to do this one. So that is going to give me. Okay, I'm going to get ux is going to come. Okay, so I'm going to use that c into f dash of x is going to come, and it is from u of x, ux of x comma 0 is going to come. So in this case, if I just substitute t equal to 0, this is going to become like 0 to 0. Therefore, the integral is not going to be there. So it is not. It is going to vanish. Only you are going to get f dash of x is the only thing you are going to get because t equal to 0 is there. So u of x of x comma 0 is going to become like ux of x comma 0 is going to become like f dash of x is going to come. Okay, therefore this is going to become like minus c into f dash of x is going to come. Okay, so therefore I can just substitute over here. Therefore this is going to become like 1 by 2c integral x minus ct to x plus ct. A of y I can write this one. So g of x into or I can write as g of y. Okay, g of y into dy minus again 1 by 2c. Okay, 1 by 2c integral. I'm going to have, okay, so c gets cancelled. I'm going to get only minus 1 by 2 minus x minus ct to x plus ct. And then I'm going to have f dash of x or f dash of y dy. Okay, f dash of y dy is going to. This is going to be your a of 1 by 2c. So this term I'm going to have. Okay, this is going to be 1 by 2c x minus ct. So I'll write that 1 by 2c integral x minus ct to x plus ct a of y dy. Okay, so this is going to be this one. Now this is going to be, this is as it is. Okay, this one is as it is. This is going to become like minus 1 by 2. F dash is that. So if I integrate that, that is going to become like f of x plus ct. Okay, minus f of x minus ct is going to. Okay, therefore I can erase this. I can write this as f of x plus ct. Okay, f of x plus ct. I can substitute it over this one. So this is going to become like minus 1 by 2 f of x plus ct plus 1 by 2 f of x minus ct. Okay, plus 1 by 2c integral x minus ct to x plus ct g of y into dy is going to come. So this is going to become like f of x plus ct minus f of x plus ct. Therefore that I can write as half into f of x plus ct. Therefore this is going to become like half into this one. Okay, half into f of x plus ct plus f of x minus ct is going to come. That's what we have in the next step. Okay, so therefore what I can do, I can rewrite this equation as u of x comma t equal to, I can rewrite this. This is going to become like f of x plus ct some function. Okay, and then my plus g of x minus ct is going to. This is going to be my general solution for our wave equation is going to. Okay, this is called, this formula is called. So if I write this one, this formula is called D-Albert's formula. Okay, this formula half into f of x plus ct plus f of x minus ct plus 1 by 2c x minus ct to x plus ct into g of y dy. That is called the D-Albert's formula. Okay, so that's what we have. So here, So this is going to be your solution is going to come. Conversely, you can take this formula, E of x comma t, you can take it and then you can verify that this is going to solve this problem. Okay, this is going to solve the problem. So you can see the beauty of this equation. So we can observe the beauty of the equation, the general solution of the one-dimensional equation, which is obtained as from the transport equation. So we use this transport equation and then we found the problem, found the answer for this one. Okay, earlier we solved the same problem using the but is that our variable separable method also we got found, and this is another method you can solve. And if you see the basic book, he used to put the other type of substitution, eta equal to explicitity and chi equal to explicitity and eta equal to explicitity, and then again he will prove the same kind of things. Okay. Also, you can do the same kind of things if you are transforming this problem to a canonical form. Suppose if I put chi equal to explicitity and eta equal to explicitity, again you can solve the similar kind of problem, and then you are going to get the answer. So now recollect that you got this u of x comma t is equal to an cos n pi by cn pi by l into t plus en into cn pi by l into t sin n pi by l x plus that. And then as I mentioned earlier, if you are using sin a plus b and cos a plus b formula, okay, plus or minus ab formula, you can rearrange this equation in this formula. Okay, sin n by an sin n pi by l into x plus ct plus an into sin n pi by l into x minus ct plus etc. is there. So this one once again I can get this thing. Okay, f of x plus ct, g of x minus ct format is going to come. Okay, that's what we are doing here. So again, you can see that this is going to be of the form u of x comma equal to f of x plus ct and g of x minus ct. Okay, one more beauty of this equation is that, okay, we observe this one. Suppose we want to find u of 0 comma t. So if you are putting u of 0 comma t, okay, you are going to use this one, u of 0 comma t. So remember this is one of the most important problem, which is one of the important question usually come in the CSAR questions, or you can say like gate exams it is used to come. Okay, so this is like u of 0 comma t if you are keeping, this is going to become like half into f of x plus f of minus x is going to come. Okay, f of okay, 0 comma t, right? So you are going to get this way. Okay, so half into, so you are going to get like half into f of ct. Okay, f of ct plus f of minus ct is going to come. Okay, and then plus 1 by 2c. This is going to become like minus ct2 plus ct g of y dy is going to come. Okay, so in this problem, suppose this is the most of the time the CSI questions or gate exam used to ask. Suppose f is an even function. Okay, suppose f is an even function. Then what is going to happen? You are going to have your gy. Okay, if f is an even function and g is an odd function. Okay, f is an even function and g is an odd function. What is it going to come? If g is an odd function, minus ct2 plus ct, this is going to vanish. So in that case, you are going to have, since this is an even function, you are going to have f of x minus ct, f of ct and f of minus ct is going to be same. So in that case, you are going to get only f of ct is going to come. Okay, f of ct or f of u of 0 comma t is going to be something like f of t is going to come. In terms of t is going to come, or you can just say like some constant you can take it and then you can take. And c equal to 1, if you are putting that, this is going to be like f of t is going to come. Similarly, if I put f is nothing but f is even, sorry, f is odd and g is even. If f is odd, then what is it going to come? This is going to be like f of ct minus f of minus ct is going to come. Therefore, this is going to get cancelled, and c is going to be 1. So therefore, this is going to be 1 by 2. Minus ct to ct, this is going to be like 0 to ct, 2 will come, so 2 gets cancelled, so we are going to get only integral g of y dy is going to come. So that's what we are saying here. So in this case, we are going to get the answer. So when g equal to 0, okay, when g is completely 0, then you can observe one more thing. The initial displacement, whatever you come with the initial displacement, that is going to split it into two parts. One is going in the left direction, another is going in the right direction. Okay, one is going in the left direction with the velocity x plus ct, okay, another is going in the right direction. So this is going in the left direction, and this is going in the right direction with the velocity, the speed is c. Okay, so that's what we have for this one. So these are all the important things which you can see. In the next class, we will see what is the how do we solve that Laplace equation in the case of polar coordinates and spherical coordinates and cylindrical coordinates. That we will see. Okay, how to obtain that and how to solve. That's what we will see in the next class. And again, this is an exercise problem. You can see that like if you put f of x equal to g of x equal to 0, what is the solution is going to come? You can observe that. Okay, if f is 0 and g is 0, So these are the conditions given. F is 0, G is 0, x less than or equal to 0, and 0 less than fx less than or equal to 1 for x greater than 0. So these are the conditions given. Then it is asking which of the following statements are true. So you can just justify your answer and then you can say like what is the solution is going on. So this one I leave it as an exercise. You can just explore it. Okay. So with this I will stop the lectures today. If you have any doubts, let me know.